My name is Konstantin Chobet. I'm a research officer. I work with NARO, and I'm based at the Eastern Institute of Buginyanya, Zadi. Today, we are going to discuss something concerning rearing fish alongside crops in the medium of water. This technology is new to us in Uganda as a country, but is not new to the world. I think we are adopting it because of the pressing need in salvaging the impacts of climate change. Aquaponics, as we shall listen from our dear presenter, mainly involves rearing fish alongside crops in an aquatic medium. The principles are three. One, minimum water use. Two, integration. And three, reduction in climate or environmental impact. So due to high demand for greener production processes, NARO found it important to bring to you this thrilling session of sharing, and mainly tackling issues concerning producing food using climate smart processes. We have our presenter in the house, Dr. Ruko Hashas, and I kindly invite him to pick up from there. Thank you, Doctor. You're most welcome.
Thank you so much, the moderator. I'm called Cassius Aruho. I work with Nafiri, ARDC. And the theme of this topic is unlocking aquaculture potential in Uganda. Ideally, we want to look at the concept of maximizing efficiency and sustainability of aquaponic systems in Uganda. We realize that in East Africa, 75% of East Africans regularly consume fish. 30% of whom consume it as their main source of protein. But also I've indicated a brief figure of the breakdown of how much aquaculture is produced in each country. Uganda seems to be leading, but the consumption of fish in East Africa is estimated roughly to be 1.3 million metric tons, according to FAO. And the per capita consumption in the East African spirit, you find that we are consuming close to 7.5 kilograms. And you can see how countries are performing. Still, Uganda, they seem to be eating more, which is about 10 kilograms per person per year. But what is important to note here is that the FAO's average per capita consumption of fish worldwide is around 20 kilograms per person per year. So meaning that we still have opportunity, we still have the gap to increase this kind of consumption, production, and then consumption. But before we dive into what aquaponics is, we have quite a number of other technology-based systems for aquaculture, not only in Uganda, but in East Africa. I'm talking about East Africa because I also know that there are colleagues who are listening from other East African countries. Aquaculture systems, of course, they range from extensive to semi-intensive, then highly intensive, hyper-intensive. They can be graded that way depending on the intensiveness of the inputs that are invested in the system. The progressing staging, of course, reflects the level of use of technology as well. And from non-supplementary feeding to highly intensive and extensive as well, intensive automated systems which are used in aquaculture. So we progressively, if we are to improve production, focus on technology innovations to make sure we transform our level of smallness in East Africa, in Uganda, so that we can produce more to meet our fish needs in East Africa. We have land-based systems like ponds, irrigated and flow-through systems like tanks, raceways, recycling system of which aquaponics is part. Then we have water-based systems. You have cages, you have pens, integrated farming systems. This is also taking root, and which is also, of course, with the aquaponics, where you have a resaturation system integrating vegetable and or crop fish farming, which is coming up, and the level of technology being commensurate with the level of operation. So it depends on the size, the input, and the ability of someone. So just a few pictures. Those are photos, those are ponds. You can appreciate the intensiveness and the extensiveness. There are those which are small, there are those which are huge investments in aquaponics systems. Sometimes you look at other systems, of course, like tanks. In Uganda, we are trying now to adopt also this system of using tanks to produce fish. There are also indoor facilities. One of them could be resaturation system. But also we remember that most breeding systems are indoor, of course, for fish. We can also use cages for our stakeholders who have not seen cages or need to understand what they are. They are just floating systems, and we feed these systems. We keep fish there. After some 6 or 7 months, we have the fish out. I talked about integrated fish, crop, and more farming systems. Some of these systems are largely high-tech. They are not already imported in this country. But of course, our focus is to make sure that they are brought to our level of management. So there are so many prototypes we can adopt and improve to make sure that our farmers here adopt those which are very relevant. As you can see, you can have chicken integrated with with fish, that is poultry and fish farming. Integrated fish and rice, that's common. We have one here actually at the NAFIRI, National Fisheries Resources, ARDC Kajansi, which is one of the institutes of NARO. And you can see this picture was also taken from NAFIRI. We have some ponds where we demonstrate growing fish and rice as one of them. So quite a number of systems like vegetables. We have our farmers we have been working with in this, especially in the central region where they have small ponds, and they are using this water to irrigate their crops around the pond, which is also a very good practice. But then now I come to what is aquaponics, having given you that background. Mr. Ondoro, my colleague, had actually touched on what aquaponics is, but it's a simple concept. You have a system of fish. As you can see, we want to call it aquaculture in this photograph. You have tanks, but this system, you are feeding it, it is producing waste, and this waste is being broken down by what we call microbes or micro living organisms, which we may not see with our eyes, but they are doing a good job to convert whatever is coming from the fish tanks into nutrients, or what we can call fertilizers for the plants. And then you have your plants in the system. And this is a simple illustration. And this is facilitated by some kind of energy. You have to have a pump. Once the plants have utilized these nutrients from the water, which is being used again and again in the same system, then the plants are cleaning this water, and this water is pumped back to the fish tanks. So it is not different from what I've shown you. This is just the system, as you have that tank, the fish tank, and then you have other units like deep water culture system where plants are grown. But you also have what you call gravel media bed. This is if you have the wastewater that has come from the tank, it is pumped, it is drawn into a system, and you have a pump, and this pump is pumping all this water, all this, whatever has come from the fish tanks, it is cleaned somehow, because this is a system that has the micro living organisms that are breaking down what all the fecal material, the feed waste that have come from the fish system. They are broken down by the community of bacteria. And then this water flows into a tank, which we may call a deep water culture system with crops. As you will see ahead, there are so many prototypes. And maybe I can talk of several types of grow beds, and those are some of what we call deep water culture systems, where you have the styrofoam hosting quite different types of plants, and it can be made of concrete, wood, whatever you may have, as long as you have the good information to use them. Then we have what we call also a system called nutrient film technique. Then you have these pipes running, as you can see, but there is a system of tanks containing fish. So this waste water fish goes through these pipes, you see, and as the water passes through, plants are drawing nutrients, or what one call fertilizers, from the system. And the plants are enjoying the fertilizers, they are growing very well. And we also have what we call media-based aquaponics system. I mentioned about this media. You must have some kind of media. As you can see, if you can see my cursor, there are some gravel material we have put. This is a smaller version of one of some of the farmers owning this. And you have crops grown here, as you can see, the berries, for instance. These are berries. And then down here, there is a tank of fish. We are feeding fish. So there is a pump, and we are pumping this water through the gravel system, where the bacteria is enjoying a good environment of reducing the droppings, the wastewater, into fertilizers, and then they are absorbed, and then the water falls back into the fish system. Several variations of the aquaponic systems that are quite affordable by smallholder systems, or rather farmers. Those are some of them, and we have some of these in this country. Yes, backyard farming, these are some of them. Those who are in Fort Portal, there is a farmer we have seen having an extensive system of this NFT, nutrient film technique, and they are doing very well, growing fish and growing plants. These are some of the versions. The farmers are very innovative. They try to get what is so big and try to customize it to get what is affordable within their means. The only now challenge is to focus on whether what has been customized by a smallholder farmer is economically viable. So I don't want to go into this science of microsystems, how organisms break down the waste water from the fish tanks, but I just want to flash, especially for those students who are interested and researchers interested in this system, those are kind of a system of micro living organisms that are involved in breaking down the wastewater to produce fertilizers for the plants to absorb. This is the same system if it is built and before you actually have the micro. If you have set up a small aquaponic system, you may take approximately 4 to 6 weeks when you have stocked your fish and then you are developing that waste and you are allowing the microorganisms or microbes to grow and be able to facilitate that process of complete breakdown into fertilizers, which shall be then used by the crops. This is the same story. We don't want to dash into this bacteria that is involved in the system. Ideally, it is a nitrification process. You are converting the wastewater from nitrate then into nitrate, and then this nitrate is being absorbed by the plants and they are happy. And of course, after absorbing, then you have clean water which goes back to the fish, and the fish is enjoying the water. Current status, how is it? What is this aquaponics in East Africa? From the East African point of view, we have so many varying systems, modifications, and the big question is whether these are really viable, and these are the questions the farmers always ask. But we estimate this kind of backyard farming to be around 25,000 units in East Africa. But in Uganda, we have over 10,000 scattered in the country. These are very small. People have them in the backyard farming, at the back of their homes, and they are doing something very small, maybe for ornamental or luxurious purposes. Some of them want to reduce stress. Some of them want to, ornamental, and some of them are just picking few vegetables. Those can grow vegetables using the same system. But what we can call medium systems, we estimate them to be around 300 in East Africa, medium systems that could be a little bit viable. But in Uganda, we have few of them, around 1,000 units, 100, which could be viable throughout in this country. Then, yes, we haven't got a clear picture of the estimated production of this, and studies or surveys are going on to establish and give a clear picture of these units, how much they produce. But those who visit ARDC NARO, they have a number of issues they come to inquire and find out and see whether some of them have them making no progress, or yes, there are some challenges, but which NARO is actually potentially able to solve so that our farmers, our stakeholders are able to use these units. Why aquaponic systems? The benefits of the system. Make no mistake, you have an area here, you will produce 10 times more than what you can produce in a small traditional agricultural space. Then there is this improved nutrient retention efficiency. Ideally, you are using the same nutrients from the same system, assuming you didn't have the system for growing crops. Then you'll have the fish waste after feeding, everything just escapes maybe from the tanks or from the ponds, and it goes into other systems. Maybe it is not environmentally safe, but when it is neutralized in this process, it is utilized in this process, then you have an environment that is really clean. You discharge wastewater that is very clean. Diversity of crops at the same time. We are having this system here at NARO, ARDC. You will see for the time being, we have been, yes, conducting a number of experiments, but we have crops, several crops being grown at the same time. And then the fish system. And then it is an easily adaptable system once we have the right knowledge. And it can accommodate in a budget as long as you can really calculate what we expect, what it can make an economic sense, which we want people to be aware of and to work towards that. Okay, there are challenges of aquaponics system. Maybe I will mention a few of them here. Adopting and customizing this system. These are highly specialized systems, and most of our clients, you find they have traveled throughout the world. Ugandans are very serious travelers. They pick and they bring a system. They start their systems without maybe getting more information, and down the road, the system is down. They cannot get this specialized knowledge. They have already made mistakes. Those are some of the challenges. So adopting these high specialized systems to our level of management could be a challenge. And then improving these so many small backyard micro systems and making them profitable is one of the challenges. But also the knowledge of climate smart. We have support tools, one of them called decision support tool, that is used to guide, to assess usage of these systems. And this helps whether to inform the user whether your environment is okay, whether you are using the inputs in the same area to make profit, all those. But the other challenge is expertise knowledge. Others are internal. Availability of the input sometimes may be a little bit costly. Then diseases could come in, managing water quality, social cultural attributes. Some people would say, hey, where did you get this fish from an aquaponic system? Oh my God, I don't like those smelly things. They are not aware that things are not smelly. Those are some of the cultural attributes. Aquaponics system is somehow labor intensive. In other words, it requires your presence and your attention, because if ammonia accumulates in your absence, you have issues, social inequalities, gender issues, use of the system, who uses it, the woman, a man, a youth, what? So people have different constructs of how they look at this. Overcoming these challenges, because we have been having several questions from different stakeholders about these systems, we try to get some kind of funding with the support of government to make sure that we set up these systems for demonstration, and we do more of the research. We generate the products, and these products we are able to authoritatively advise farmers that do this, adopt this, don't do this. And this is what we did. This project was funded by, is actually still owned by European Union, and it is helping us. We have designed a system, as you can see, the tanks, the media beds, the deep water culture, the NFT, nutrient film technique. This is just a design, maybe for some few are interested, but this one was designed for research so that we have systems for replicates and you have good information you can pass over to the stakeholders. This is just showing you the system where we have we set up the system at ARDC NARO, right from site clearance, construction of the structure. You can see how beautifully the completed structure inside is, but largely, as I say, using it for research purposes and yes, quite have some technology that is helping us monitor all the water quality parameters and controls, which probably a smallholder may not need to have, but of course, this one helps us to optimize and advise this smallholder. What can you use? Don't use this high tech. This is so much. This is maybe not very necessary for some specific sizes of the systems. So we have been stocking, have that is the system inside. We have the fish enjoying water. You can see in those pictures. Then we have these are the fish tanks, and then the deep water culture systems, and then the gravel system. Uh, and then you see the deep water culture. You have some plants we have grown there. Um, yes, um, so many experiments. We just optimize the system for our use here to produce good results, and also optimize the system to get information that the farmers could use for uh, for their own systems. These are just pictures. It's part of the management. How do you manage? How do you plant? How do you And of course, we have had some big space in the system. We constructed the shed as you saw it, and you don't throw it away. We use the same wastewater to plant quite a lot of, in that space, potted plants. We have them. They are growing beautifully. You can see sukuma wiki, you can see the tomatoes, you can see the lettuce, what we are producing in the system at NARO Kajansi. You see, this is much of the science, kind of sampling the fish, the tomatoes we are eating, some of them we are selling. This is just snapshot of the tanks, the pumps that are used in the deep water culture. You can see, so we have had actually a lot of engagements, especially through training, generating this information into brochures. And then we have had a number of students, other stakeholders visiting the facility to come and see, acquire some basic understanding of the designs, and then the best management practices. We have, yes, some days where we need to create awareness and promote these technologies. We have been doing this with some other partners in the country. So these are some of the materials. Those who are close to NARO, please, you come, you pick some of this information. I can't discuss everything and what we produce here. But we have quite good information. When you come visit us, you have these brochures, we have discussions, you look at the system, how it is run, you get a better picture. So this is designs that are summarized for the farmers, and we try to work with partners sometimes to customize them to whatever level you want, as long as we are sure it makes some sense in it, some economic sense. Um, and demonstrating what we are doing there. Moving forward, capacity building is one of the key issues that NARO wish to promote. Our stakeholders really, they want to understand what is it, what systems, what, so many questions, technical training, the students, we have students who are doing the research at the system, they are also being helped. We want to create awareness. That is a continuous thing. Training, as I said, is very important. Working with communities to support modifications, to customize the system is what is very important. But sharing the knowledge, and knowledge of these systems is scarce. So we need to bring the knowledge of different experts, and then we help these farmers, and then we have this kind of knowledge at NARO. And of course, we are promoting backyard, not backward, backyard farming for a number of reasons. But then we need to help farmers get the right information. We have systems. We now use solar systems. We don't use this. Solar system is energy. We want our people to know what is cheaper for them that they can use. These are the system used for, probably energy used for water exchange. And these systems are they are handy for youth. They are handy for women, especially those who are doing backyard farming. And then also promoting marketing of high value crops and fish, high value crops in this aquaponic system. Not these usual systems. The vegetables, most of the vegetables, some of them, they are high value and they are accommodated by this system. I want to thank you so much for your patience, but I also want to ask my colleague at some point, he has to show our dear stakeholders maybe brief economics of what this aquaponic system means. But maybe Dr. Barre, I don't know whether you are hearing or listening to us, you could just at some point when it comes up, please, you can intervene and try to explain. Otherwise, thank you so much. I have colleagues I work with at NARO, and these are also experts in aquaponics. So as the moderator opens the platform for discussion, and any colleague of ours can try to respond to some of these questions, depending on the technical expertise. There are some colleagues who are specialized in designing, then those who are specialized in crop production, then fish. So it's a team, but a team comes together, they can have a number of, responses they can respond to, depending on what the stakeholders are interested in. Mr.
Thank you very
Moderator,
much.
I want to
Thank you
thank
very much.
everybody for listening.
Thank you very much, Dr. Ruho. I think you have done us a very good job. Now, dear stakeholders and members of the NARO fraternity, Dr. Ruho has done us a very good job by saving us a few minutes. And therefore, now we kindly invite you to interact with us in terms of answer questions, whatever was not very clear, or you have some information to share with us, you're most welcome. We are going to have 5 minutes to take questions, and then we shall give Dr. Ruko 10 minutes to respond. And then later, we may, if time allows, we may give another 15 minutes for more set of questions and answers. You're welcome. You probably raise up your hands and we allow you administer your questions. Thank you. There is a question from Dr. Kajimu. He wishes to know which nematodes are involved in this process of aquaponics.
Ideally, we want to bring our stakeholders to the attention of this system, especially when we talk of the microbes that are largely involved in this system. So we actually have quite a lot of them, but the bacteria is the one which is very key, the one that converts the wastewater. I think I don't know whether I'd shown it somewhere. So this bacteria, the nitrobacter, that converts is involved in the nitrification process to break down the ammonia that has accumulated, and then the bacteria that breaks what the products, the nitrate oxide products, into nitrate. So it's not much of these nematodes we are talking of.